These models know way more than they show, and they normally just tell us what we want to hear. We still have very little insight into these AI models. Our ignorance kept growing as companies became more and more private and models more and more complex. We sort of had some guesses, but Anthropic published a beautiful research into the mind of the AI, and it turned out we weren't even close. So let's first set the stage. You might have heard that AI is like a black box. Words go in and words come out. But we don't know why it said what it said. That's because AIs are not programmed, they are trained. And during the training, they learn their own strategies to solve problems. We need to know what the AI is thinking, mainly for safety reasons. If we don't know how they arrive at a response, they might just say what we want to hear, but have other thoughts inside. That's why we need to open the black box. But even opening the black box isn't that helpful, because we don't know how to interpret what we see. Just like a neuroscientist investigating the brain, we need tools to figure out what is going on inside. We need to know how the model connects all the concepts in its mind and uses them to answer our questions. Researchers at Anthropic have developed ways to observe some of the AI model's internal thoughts, and they used it to answer 3 questions. Claude writes text one word at a time. Is it only focusing on predicting the next word, or does it ever plan ahead? Claude speaks dozens of languages. What language, if any, is it using in its head? Claude can write out its reasoning step by step. Does this explanation represent the actual steps it took to get to an answer? Or is it sometimes fabricating a plausible argument for a foregone conclusion? So let's answer the first question. Does the AI ever plan ahead? Keep in mind we are talking about the normal base models, not the thinking ones. Let's take a simple example. They asked Claude to write the second line of a poem. The poem starts, "He saw a carrot and had to grab it." We expected the model to generate one word at a time to complete the second line. But instead, Claude sees a carrot and grab it and thinks of rabbit as a word that would make sense with carrot and rhyme with grab it. Then it writes the rest of the line. His hunger was like a starving rabbit. They look at the place that the model was thinking of rabbit. And they also see the word habit is present there. The new method allows researchers to go in and suppress the word rabbit as the model was planning the second line. And they observed that the model changes all the previous words and writes, "His hunger was a powerful habit." This means that the model is obviously anticipating a certain word at the end and writes the line toward that conclusion. This is a simple example that shows models are actually planning ahead of the time, not just generating words one by one. So that answers the first question. By the way, that was Anthropic's animation right there. But the second question takes it even further. Does the AI think in a specific language? Does it even think in words? For that, they had a clever idea. They would ask the same question in different languages. If there is no overlap between the activation patterns, that means the AI is thinking in words, and each language has its own path on the network. So they asked, the opposite of a small is in English, Chinese, and French. And it turned out there is a lot of overlap. The model has specific activation patterns that repeat in all languages. The patterns that represented the concepts small, antonym, and large activated every time. This means, as opposed to what a lot of researchers believed, even Yann LeCun, one of the pioneers of modern AI, the chief AI scientist at Meta, these models don't think in words. They immediately turn words into concepts and do all of their calculations in a latent space. Then they translate their thoughts into words at the very end for the output. Not only that, the shared circuitry of these languages actually increases with the size of the model. The bigger the model, the more conceptual overlap it finds between languages. It also suggests that the model can learn something in one language and apply it in other languages. But the most surprising one is the last one. Does Claude ever misrepresent its own thoughts and reasoning? This one is very interesting because in the process of answering this one, they found something way more important. So, in this example, researchers asked for some simple math. What is the answer to 36 plus 59? Has the model just memorized all the additions? Obviously, no. They found some computational paths that light up for additions. I'm not sure if other people do this, but this is exactly how I do additions. One path computes a rough approximation of the answer, and the other focuses on precisely determining the last digit of the sum. Then it combines the two to produce 95, and that's correct. Then they asked briefly, how did you get that? The AI responded, I added the last digits, then carried the 1, then added tens, and the standard calculation for additions that we learn in elementary school. This means the AI is telling us what we want to hear, regardless of what it is actually thinking. And that's sort of dangerous. But it might not be the AI trying to deceive us. It might be that the AI is unaware of its own complex calculations. But here is the crazy part. This also means that the AI has already developed a lot of insights and mental models that doesn't match human models, but it is unwilling or unable to articulate them. I mean, this simple addition strategy might be nice to know. And the AI already performs much more difficult mental calculations, so it has developed internal strategies and models that are completely different from humans. And it doesn't stop there. AI most definitely has unique mental models in other domains, but it is sort of sealed inside the box. If you think about it, every scientific breakthrough comes as a result of some scientists having a better mental model compared to everyone else. But current AI models don't seem to be willing or able to play with their own actual mental models and heuristics. Even thinking models are producing thoughts that are not faithful to the actual process. This might be solvable, or we might actually be incapable of comprehending what they know ever. Take AlphaFold for example. We would never understand the patterns inside that model. It's just impossible for us. Similar things might be happening in LLMs. There are more examples in the actual paper, and I leave a link to it in the description. Hope you have a nice day.